Our next speaker is Johnny. Johnny Saetre leads VDC implementation teams at Veni, Norway. He's been an early user of VDC, and he's going to show us today a case study of applying VDC on one of the most innovative food processing plants in Norway. Over to you, Johnny.
Thank you, Talika, and thank you, Martin. I'll just get going and we'll see where we end off. Hi everyone, I'm here to tell you about a project that my colleagues and I have been working on for the last 4 years. It's a chicken processing plant in Norway. Just quickly before I go off, I run a department of 10 highly skilled VDC professionals, and we operate at a project and organization levels as VDC consultants. So the interesting setup of this project is that the building owner and the building users are both owned by Reitan Retail. It's a company behind Rema 1000, which is one of the largest single grocery store chains in Norway. So Rema 1000 now have control over the entire supply chain of the meat that they are processing and selling. So this project opened 2 weeks ago, and we'll be looking at the outcomes of this project. So one of the biggest greenfield poultry factories ever built in Norway, if not the biggest, I don't have the exact numbers on it. It's a 2-story production building, which is unprecedented because there's lots of new and other types of challenges to solve. Not usual setup, production lines over 2 stories. They did it to save areas and then cost, of course. So funny discussion initially, because we're talking about client and project objectives, how hard they are. One might almost believe that I set up this conversation beforehand, but I actually didn't. So coming into the project, the client said they had a list of quite ambitious objectives, as you can see. But they're talking about they want to be the best in the world at the lowest prices and innovation within a wide array of topics. And one might wonder who is paying for these ambitions. Let's see if we find out later on. So here's an obstacle many VDC professionals meet, and we recently discussed. How can we create project objectives that support client objectives if the client objectives aren't target defined and you are in a project where you have limited impact and influence on a project? So for us, being a consultant inside one of these teams, there were 14 teams actually in the organization at the early stage. The influence you have on the project as a whole at an early stage is quite limited. So how do we go about this? What do we do? As I said, creating project objectives are hard when it comes to supporting best and lowest. And of course, we don't have always the influence to apply the entire VDC framework. So the best we could do for this early stage, we set up the project objectives for our team is that we could finish our scope on time and on budget. But how do we leverage VDC to make the best project possible from our standpoint? Well, we had to look at what was at our disposal. Of course, besides the most important and obvious one, the right skilled people in the right place. The best we had in our VDC toolbox, it's controllable factors and performance metrics. We need to decide what gives value for the project, and we need to measure it as we go. So one of many aspects of this factory hasn't been done before. So we needed to create a certainty of product and a certainty of process just to secure predictability and really making the client trust the work that we have been doing. So we needed to develop a thorough and highly detailed design development. So I'm just quickly going to sum up the design development stage because we're moving on to the next one. But through this 11-month period, we ran 120 eye sessions. We created a BIM with the LOD 300 for the entire building team design, and we used pool plan to create predictability in the construction. So it was planned to create certainty of process, to convince stakeholders of the project's feasibility. And we decided that the best way to do that with so many one-time project stakeholders was to simulate the project execution. So here you'll see 1 year construction in 1 minute, basically. On top, you can see the calendar and the actual estimated value on the project at any given time, because it was connected with BIM, budget, and the 4D. I hope you can see my movie and it's not lagging, but I'll pretend that it's rolling.
We see it, Johnny, perfectly.
That's great, thank you. So as you can see, the client was extremely happy with the design development phase and the outcome of it. And he was happy with our contribution, even though we had a low level of influence at an early stage, that our influence grew and confidence in the VDC method grew as well. But looking at the next stage, how can we make a positive impact on the project as VDC consultants for the client? General contractors are now on board and they are in control of the project execution, along with up to 15 different machine suppliers, creating the machines that are going to process the chicken. So if we look at what's the purpose of the building, why are they building this? It is, of course, the processing of chicken. It's not for the building's sake. So when we went through the design development stage, the team that designed the machines and equipment, they were non-VDC. They were 2D CAD layout. They had 15 different suppliers, each with their own set of 5 to 15 sub-suppliers. Our data was spreadsheets, data sheets, machine specifications, and PDFs. So what you're seeing now is basically what we had to work with for the information to design the building. The problem is there were many discrepancies and misunderstanding between the spreadsheets and the CAD and the data sheets, as they often had a tendency to change names. They changed the location of where the connection points are. They changed the power need and so on. So building designers were really lacking understanding of the geometry, where to connect, how many connections are there, what types are there, how much utility is needed, and so on. So that was a big difference in coming from a VDC team and over to a team where there was a lot of different things of doing, ways of doing things. So we needed to come up with a solution that could work for all stakeholders and have a precise basis of what the building was going to support. The suppliers, of course, had 3D files, but they were made to produce the actual machines. And when we look at these at a BIM perspective, they're too detailed. They had zero information. The files are huge, and the suppliers actually won't share their files, of course, to business secrets inside the machines. So our solution that we designed, we've called it Process BIM. So the name simply comes from bringing together the world of food processing and the world of BIM to Process BIM. We needed to be integrating information into one single source of truth using eyes and visual programming in BIM. So we went through different stages of standardizing, simplifying, but enriching data that we need and removing data that we didn't need. Creating understanding and merging all together into one BIM file, basically. So the process BIM is what you see here. It is BIM containing all information needed for building designers. We look at this now through a CDE called BIMsync. It's a Norwegian software where you can upload models, issue handling, documents, and it all works together in one great symphony where you can connect BIM objects to issues and to other documents. So if you take a look at the properties on the right for this machine here, it describes the need that this machine has for gas, power, vacuum, signal, high pressure air, which operating weight, decibel level, tags, and any other identification you need to see, all visible for everyone in the project. So we ended up creating about 3,900 process BIM objects with 1,700 connection points for 500 plus people. They were all seeing the same thing. So going into the detailed design with especially the MEP trades, how could they leverage this information? How could they use it? Well, in addition to all information available on BIMsync, the architects and engineers had the same information available directly inside the Revit, ArchiCAD, or BIM software. So they can actually design connections and building supporting systems. Now imagine this level of access of information for all engineers and architects directly in your own BIM software. Yes, the outcome was, of course, we have now a digital representation, so we can use for design, construction, operation, and facility management. Moving on to another example of core drilling and cutouts. We had 15,000 square meters of precast concrete in this project, and we need to penetrate them some places. And the general contractor for the building said, we have BIM objects crossing our structural system. Is there any way we can automate and find out how we can place these out with the data that's actually in the model? But when you look at the organizational map, the client needs to come up with a good solution for this coordination work. So if you look at this point, we had basically removed most of clashes between MEP objects and the web and the precast concrete. However, the void that we need for an object is bigger than the object itself. And if you see to your right here, the web on this structure has a no-go zone where you cannot penetrate this, and the object is quite close to it. So how do we identify a clash that will be there in the future when it's not modeled? So we weren't able to detect it at that point. Another challenge that we needed to address is that any opening in a structural floor represents a risk. In this case, however, the hygienic risk was quite large. So if you have containment between rooms or stories, worst case scenario, we needed to shut down production, which will be quite costly. And the operation cost of a hygienic breach is also extremely high. So we needed to keep a number of voids to an absolute minimum. So again, we needed to come up with a solution that collects data, existing data, and distributing around in a consistent way. So as Martin was saying, we needed to find a way where information was working for us, and we didn't need to work for the information. So we came up with a process between us as consultants and the GC, where we basically ended up creating a BIM for each void with the entire width of that void. So we could run clash detection between the BIM objects and the actual structural objects. We then exported this and send it to the layout or surveying team so they could pinpoint the exact location through the coordinates that was in the BIM or the CSV file that we exported. So the result from this, you can see a snapshot here from one of the voids. Each void had 30 properties collected from the spreadsheet that the GC filled out. It inherited properties from the BIM objects that were actually penetrating the floor, so you can always know which object this void belonged to, and so on. So we were able to identify with the rules 526 penetrations, and we gather those together with 366 shared voids. Now, practically all voids were placed correctly for drilling and sawing from a quality assured BIM, which could only be done because we had the combination of process BIM combined with these BIM voids that we call them. So combining process BIM and BIM voids, you're now able to solve a lot of issues that you normally can't at an early stage. One example is the machines that you're looking at here was quite complex on the inside. Their wastewater outlets clashed with the web, actually, which from the example we just saw. The room and machine layout already was tight and optimized, and detailed design was finished. So changing the placement of the machine now with as little as 20 centimeters would cause substantial delay on the schedule. We were able now to solve this issue, and actually the machine supplier had to go back and redesign the machine because this was pointed out in an early stage, and now so this worked out good and no extra cost for the client. So if you take a look at how many different stakeholders were involved with solving this issue, at least this many. Now look in the snapshot in front of you and imagine solving this issue with confidence. If the only information you have is a 2D plan view, not knowing 100% where the outlet is, and we have a concept BIM from the rest of the group. How costly could this issue become if it couldn't be discovered until all the machines are there on site, when actually money is running down the actual drain, or we're falling behind schedules, and the solutions that we end up with are just what we ended up with, the best we could do with what we have. I think of how many issues like this will appear on such a huge and a complex project. So my question is, do the audience think that the process BIM and the BIM voids made an impact on the project? Let's find out. If we look back, did the client achieve the client objectives? According to them, yes, they did. But without targets and numbers, how can we know? If we try to look at it in another way, if we look at the definition of a high-performing building, as Martin discussed, what are the measurable values at the opening day for this project? The performance and the criteria that fall under the category usable and operable, we won't know until the plant has been running for a while. So we'll get back to that in a year. But if we try to categorize what we know today under the categories, it would look something like this. Under sustainable, they have great solutions within energy, agricultural sustainability, animal welfare, high quality, lowest price in the market, CO2 emissions, a lot of awards picked up. So they increased the animal welfare in this process, and they are energy efficient. They won awards for low climate impact. Their farmers are the best paid farmers in the market. They have the lowest prices in the market while they are still being a profitable business. And if that doesn't check the sustainability box for you, I don't know. It's quite amazing results. So, but how can we make sure their business case is a sound one? Well, for us, it's to make sure that the project is buildable, AKA we needed to put it up on time, on cost, for the right quality.
Johnny, last 4 minutes.
Yes.
I need to do this, but.
Thank you. So they ended up being on schedule. They were actually 2 months ahead of schedule before COVID hit, and they came in under budget. They were significantly under budget a while ago, but they saw they were going to make it, so they wanted to spend their contingency to just increase the quality of their building. So I've been interviewing 4 key stakeholders in the project, among the CEO of Norsk Kylling. He said that for a project of this magnitude and complexity to finish on time and under budget during a pandemic is nothing short of unique. And 10 to 15% over budget for this type of project is not unusual. We actually heard of projects going 40% over budget as well, and they were not as complex as this building. So we are really glad for the client. We asked the interview base to give us some success factors. So if you look at the list defined by the client and the top project management, most of them, basically for me at least, are VDC fundamentals. A high level of coordination was picked up by one of the manager, and as Professor Fisher always points out, one way or the other, you will pay for coordination. So the question for me is, do you want to do it virtually with data you trust, where everyone sees the same thing, proactive solutions are met with the lowest cost possible, or do you not want to do that? So that was a short list of success factors, but they had a couple of more which are must-haves to secure the project success. So he basically described VDC, the right people with the best technology working in an appropriate design structure, always striving for improvement is the best way to succeed in a project. The reason why I showed you the design development 5D Lite was 2 of the key stakeholders said that this was crucial to secure the project success. Finally, one of the things that made me glad was finishing on time and under budget would not have been possible without the creation and the implementation of Process BIM. Now, if you look at these 3 crucial points for project success, what do these 3 points have in common? Well, they're actually all controllable factors. There are things that the project at one point could just decide to do. So if you look back to the start of the presentation of how can we make an impact on a project, even if we are just a small piece in a big picture, well, for me, it's finding controllable factors that you think will contribute to project success. And if they're good, at some point, someone with influence in the project will see it and it will help you make it happen. So in my opinion, of course, if you can implement VDC in a big picture in lots of areas, that would be great, but even a partial VDC application can help secure massive value for the client. Just 1 minute about Veni and then I'm done. The industry, as you see, has a lot of great BIM tools. However, there's very few great VDC tools. So that's why we have developed our own suite. We call it Life at Site. It has modules for project development, project planning, and execution stages of the project. We're launching these within a few weeks. So if you're frustrated by the lack of good VDC tools out there, connect with me on LinkedIn and we'll spread the word as soon as they're ready to launch. Veni also has software for building owners and tenants called Life at Work. So I want to thank my brilliant colleagues who made all this possible and makes it, for me, going to work each day, it is a thrill. Thank you for your attention.
Thank you, Johnny. There's one question. Catherine, you want to ask it?
Yes.
Ask the question. You have to just be very quick.
Yes, there's one question here. Well, I'm actually wondering what goes through your head when you go into KFCs to eat now after that chicken fabric project.